Welcome to part 2 of the video for section 3.6. Please continue by finding example 4 of the modules. Example 4, finding the zeros of a polynomial function with complex zeros. Find the zeros of 2x to the fourth minus 3x cubed plus 9x squared minus 12x plus 4. So there are a lot of zeros here. This is a fourth degree polynomial, so we need 4 zeros. Not all of them may be real. So this is going to be kind of a long drawn out example. Let's start by using the rational zeros theorem to find all possible rational zeros. So a naught equals 4 and a sub n equals 2. My possible factors are plus minus 1, plus minus 2, plus minus 4. Here I have plus minus 1 and plus minus 2. This makes all possible rational zeros as plus 1 minus 1, plus 2 minus 2, plus 4 minus 4, and we also have plus 1/2 and minus 1/2. So 1 over 1 gives us 1. Negative 1 over 1 or 1 over negative 1 gives us negative 1, and so on. You can take a look at this yourself. 1 over 1, 2 over 2, 4 over 1, 1/2. 2 over 2 is just going to give us plus minus 1 again, and plus minus 4 over plus minus 2 will just give us the positive and negative 2. So these are all our possible rational zeros. Take a moment to evaluate your function f at 1, at negative 1, at 2, at negative 2 again, at 4, at negative 4, at 1/2, and at negative 1/2. So again, please pause your video and plug in all 8 of these values into this polynomial and write out just the answers here. So please work these out on some scratch paper. All right, please verify that you have f of 1 equals 0, f of negative 1 equals 30, f of 2 equals 24, f of negative 2 equals 120, f of 4 equals 420, f of negative 4 equals 900, f of 1/2 equals 0, and f of negative 1/2 equals 12 3/4. Which ones, by all the theorems we've been learning so far, are actual zeros of this polynomial? Well, f of 1 is a 0 and f of 1/2 is a 0, since they are equal to 0. The rest of these are not zeros of this polynomial. So where does that leave us now? We have to find the complex zeros of this polynomial. And we know that x minus 1 is a factor. And we know that x minus 1 is a factor and x minus 1/2 is a factor. So we know x equals 1 is a 0, which tells me that x minus 1 equals 0, so x minus 1 is a factor. We also know x equals 1/2, so 2x equals 1, or 2x minus 1 equals 0. That means these two are both factors of this polynomial. So let's go ahead and use this information to help us further factor this polynomial. Let's do some synthetic division here. So I have 1 on the outside, 2, negative 3, 9, negative 12, and 4. By now you should be comfortable with synthetic division, so please pause the video again and work out the synthetic division here. All right, so we end up with 2x to the fourth minus 3x cubed plus 9x squared minus 12x plus 4 equals x minus 1 times 2x cubed minus x squared plus 8x minus 4. Now we can go ahead and factor this polynomial by grouping. So I'm going to go ahead and move things around just for spacing reasons. So let's continue factoring this. We have x minus 1. And then what did these have in common? This group here has an x squared in common. So I can factor out an x squared, and I'm left with 2x minus 1. And here I can factor out a 4, positive 4, and I'm left with 2x minus 1. If you notice, this is precisely one of the zeros that we already verified. So now we have x minus 1 times 2x minus 1 times x squared plus 4. And this here is where our complex zeros will come from. So go ahead and take a moment and using the quadratic formula with a equals 1, b equals 0, and c equals 4, find the two complex zeros of this polynomial. As a refresher, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. And if you haven't memorized this already, you are digging yourself into a pretty deep hole by now. You need to have this memorized. The sooner, the better. So please, if you have not memorized the quadratic formula, take this as an opportunity, as a reminder to please memorize it. And now please pause the video and work this out. All right, so as you can see, I worked out using the quadratic formula that my last two zeros, which are complex, occur at 2i and negative 2i. So all of my zeros are at 1, 0, 1/2, 0, 2i, 0, and negative 2i, 0. So these are all the zeros of this polynomial. With that, turn to the top of the next page so we can look at example 5. This is also the last page of section 3.6. Example 5, finding a polynomial with given zeros. Find a fourth degree polynomial with real coefficients that has zeros of negative 4, 5, and I such that f of 2 equals negative 100. So our zeros tell us that x equals negative 4, x equals 5, and x equals I. Now, since x equals I is a 0, what else do we know? What theorem should we reference here? If you recall, the complex conjugate theorem tells us that if a function f has real coefficients and a complex 0, so here we have our I, that's a 0, then its complex conjugate must also be a 0. So we know that x equals negative I is also a 0. So this tells me that my factors are x plus 4, x minus 5, x minus I, and x plus I. So f of x equals some constant a times x plus 4 times x plus 5 times x minus I times x plus I. So we have a times x squared minus x. Oops, there's a typo here, pardon me. X minus 5. So we have x squared minus x minus 20 times x squared plus 1, which works out to be a times x to the 4th minus x cubed minus 19x, minus 19x squared minus x minus 20. Now we need to figure out what this a is using this information here. I'm told that f of 2 equals negative 100, so I have 2 to the 4th minus 2 cubed minus 19 times 2 squared minus 2 minus 20 equals negative 100. So I have A times we have A times 2 to the 4th, which is 16, minus 2 to cubed, or 2 cubed, which is 8, minus 19 times 4. This is negative 76 minus 2 minus 20 equals negative 100. After all this, you should end up with negative 90A equals negative 100. So A equals negative 100 over negative 90, which is just 10 over 9. So our final polynomial is 10 over 9 times x to the 4th minus x cubed minus 19x squared minus x minus 20. Finally, let's look at Descartes' rule of signs. Descartes' rule of signs, let f of x be a polynomial function with real coefficients. So that is, these a's are all real coefficients. The number of positive real roots is either equal to the number of sign changes of f of x or less than the number of sign changes by an even integer, or the number of negative real roots is either equal to the number of sign changes of f of negative x or is less than the number of sign changes by an even integer. Let's see what this means. So let's find positive real roots, or the number of positive real roots. And the number of negative real roots. So f of x equals x to the 4th plus 2x cubed minus 12x squared plus 14x minus 5. Let's see, how many times do we change signs? Here we go from positive to positive, so there's no change. But from the x cubed to the x squared term, we go from a positive 2x to a negative 12x squared. So this is from a plus to minus, so that's one change. And then immediately we go back to a plus, so minus to plus. And then finally we go back to a negative again, so this is plus to minus. So that gives us 1, 2, 3 sign changes. This means we either have 3 positive real roots, or, let me scooch this up real quickly. I don't want this to be cut off. Or we have 1 positive real root. And this is due to the fact that 3 less an even number of 2 is 1. Now let's look at the number of negative real roots. So we have negative x here is our input. So let's see what this looks like. So this becomes x to the 4th minus 2x cubed minus 12x squared minus 14x minus 5. And let's see, looks like here we only have one sign change from positive to negative. So this is one sign change. The remainder are all negative. This tells me that we have one negative real root, or no negative real roots, so 0 negative real roots. Let's quickly graph this, but rather than using a graphing calculator, I'm going to use the Geogebra software. You should be downloading this and using it at home since it is completely free. Here is the Geogebra software. And now from your notes, we know we need to graph the following polynomial, so click here on the input bar and type in y equals x to the 4th plus 2x cubed. And if you want these exponent symbols, look at your number key at 6, and you just need to hit Shift 6, and that'll give you that exponent symbol. Minus 12x squared plus 14x minus 5. And let's double check that we typed this in correctly and take a look at the polynomial. Oh, look at this. So if you want to see the whole thing, click on the Move Graphics view. And then notice that this cursor changes icon when I'm on the y-axis, and I can drag and squish this whole thing down. Look at that. That's beautiful. I can do the same thing on the x-axis. So I think this is a really nice view here, and this tells me that this is my function f, which is x to the 4th plus 2x cubed minus 12x squared plus 14x minus 5. And if you notice, we do, let's see, there we are. We do have one negative real root at -5, so this is x equals -5. So as an ordered pair, this is -5, 0. That's one of our real roots. And our other real root is at 1, 0 here. Since this is a 4th degree polynomial, we know that our two remaining roots have to be complex or have some imaginary number I in them. This concludes the lecture for section 3.6. I do hope you'll be downloading Geogebra soon. I'll put a link in the description below in case you don't have it already, but it has been on Canvas all semester. In case you haven't downloaded yet, now would be the time to do so. You can verify all the results we obtained in basically this chapter that we've been looking at polynomials using Geogebra.